first what we have to do is draw a diagram. And as you see here, we have a lengthy word problem. This is definitely a geometry problem, so we have to draw a diagram. Okay, so two parallel curves. So two parallel curves right here. Curves are basically like streets or basically just straight lines, and they're 40 feet apart. So if they're 40 feet apart, we can draw this, a straight line, both perpendicular to both of them, and they're 40 feet apart. So 40 feet apart. And we have to continue. A crosswalk bounded by two parallel stripes crosses the street at an angle. Okay, so two parallel stripes cross the street at an angle. So we have two stripes right here. They're parallel and they cross the street at an angle. The length of the curb between the stripes is 15 feet. So the length of curb right here, this is the part of the curve. The length of it between the stripes is 15 feet. Okay. And each stripe is 50 feet long. So if each stripe right here is 50 feet long. Okay. Find the distance in feet between the stripes. So like between the stripes right here, that's what we're looking for. We'll just name it as X first. Okay. So what we first can do is look at any possible triangles or anything that will help us in general. And as we see here, we have a 3, 4, 5 triangle. Okay, so we have 40 feet apart, right? And then this is 50, so this stripe is 50. So that means this part of the curve is 30 feet. Okay, we don't know if it's going to be helpful, but at least we listed it for right now. Okay, so we have 30 feet, and we're trying to find X, as we know, and we can move X up here. So if you have X right here, then it will be helpful. And if we zoom in on the X, and I'll make a bigger diagram of the X. So the X is like this. The lines are parallel, so the stripes are parallel. And let me draw that better. So the stripes are parallel, and we have like something like that. And this is X. So we know that this is a right angle. The reason why we know it is a right angle is because these two are parallel, the stripes are parallel, and if we're drawing an altitude, that means it's perpendicular, or 90 degrees. So there's a right angle at right here. Okay, so we know we have a right angle right there, and we also know that this is 15, because just like we could have drew this 15 up here as well, just like whatever. It says the length of the curve between the stripes is 15 feet. Okay, so we know this is 15 for sure. And as you see here, we can also draw another right triangle, because we're trying to find similar triangles that will help us solve the problem. And as you see here, let me first erase this. Okay, so we have a right triangle here. This is 50 feet, and then this is 40 feet. This is 30 feet. Basically drawing everything over here, and then replicating it over there. We could have drew it both ways, either side. I'm just drawing it again. Okay, and as you see here, wow, we found similar triangles. Okay, so we know that this is a right angle because we're drawing the altitude, and this is a straight line, 180 right angle, and so we know if we continue off here, and then let's just draw right here, we know that this, so we can, we'll just name this Y for right now, this angle Y, and we know this is a right angle right here. We have similar triangles. Okay, so this is Y, this is 90 minus Y, because if you add up every angle on the straight line, equals to 180. And then that means this is also Y. Okay, so we have this similar triangle right here. This large triangle is similar to this small triangle, and then we can find X finally, what we want to find out. Okay, so we know that the hypotenuse, we can draw a ratio diagram. So we can write a ratio. So we have 15 as the hypotenuse of the smaller triangle is over x, which is what we're trying to find. And the hypotenuse of the bigger triangle is over here, as we see, 50 feet. So I'm going to write a ratio. And then right here, this is the most important part. As we see here, this is x. We have to find the side corresponding to x. And you can kind of just paint a picture in your mind. It's like this, x, 15. No, sorry, not 15. 15 on the hypotenuse. We know that x is equal to 40. 40. That's how you write the ratio. Okay, so 50 over 40 is equal to 15 over x. And that's how we find x. But we want to make sure, this is the most important step, you translate each part of the diagram onto the ratio correctly. So we want to find the correct side for x, which we already did, which is 40. But don't make sure it's not 30 feet, but you can also use the angles to prove it. Okay, anyways, we have 15 over x is equal to 50 over 40. 50 over 40. So we can multiply. So 15 cross multiply. 50 times 40 is equal to 50 times x. 15 times 40 is equal to 50 times x. And then we get x is equal to 12. Also, if you don't want to cross multiply, you can just multiply by 40x on both sides. And then we have 40 times 15 is after the x cancels out. So the x cancels out. 40 times 15. And then we also do it on this side. We want to make sure that it's even. And then the 40 cancels out. Equal to the same result. Okay, so x is equal to 12. And yeah. So the reason why I filmed this